Hello class. In this lesson, we're going to learn about the exterior case for the secant angle theorem. So here we have secants that intersect outside of the circles, and we have the measurements of the external angles labeled along with the arc measurements, the intercepted arcs. And what do you notice about those measurements? What do you think the relationship is between the external angle, the larger arc, and the smaller arc? Well, if we do something like we did with the interior case, we would add the arc measures together and divide by 2. But that gives us 74 for the first case, and this is 30 degrees, so that's not correct. So let's see if we can tweak this a bit. Instead of adding them together, let's see what happens if we subtract them. And we do get 30. So it looks like that gets the job done for the first one, and if we do the same exact process for the second circle, it works out. So it looks like we're going to subtract these arc measurements and divide by 2. So let's prove that. So in this case, we want to show that x is a minus b all divided by 2. So we want to do a construction here. So let's draw in DG, because this gives us some inscribed angles, and those are going to be helpful. So what are the measures of angles EGD and FDG? Well, they're going to be half the measures of the intercepted arcs. So EDG is half of A, and FDG is half of B. And we can write an equation using what we know about exterior angles of triangles. So let's look at triangle CGD and exterior angle EGD. So how can we relate the measure of angle EGD to the measures inside this triangle? Well, it's going to be equal to the sum of the two remote interior angles. Right, so that's going to be GCD plus FDG, those angles measures. So now, if we substitute, what do we get? Well, we plug in what we have up here, and GCD was our x. That's our exterior angle that we're looking for. And now we can just solve this for x, and this gets us our desired result. And this holds for other cases where we have tangents involved. So here's the case we just proved with two secants, but it also holds if you have two tangents, or if you have a secant and a tangent. You just subtract the measures of the intercepted arcs and divide it by 2, or multiply it by 1/2. And always make sure that you put the larger arc first, or else you're going to get a negative angle. So let's apply what we've learned here. So in example A, what are we going to do? Well, x is going to be equal to half of this difference. And so our answer is 28. Now in B, they only give us one arc measurement. However, these are two tangent segments. And if this is 252, we know there's 360 degrees in the whole circle, then this is 108, right? 360 minus 252 is 108. And so we apply the same process and we get 72. All right, and here's an example that requires some algebra. So see if you can set this up and solve it, and then I'll show you my solution. So we have our external angle measure, that's 34 degrees. So we're going to subtract these two and divide by 2. Now be careful when you're subtracting here. You got to remember that you can think of it as distributing a -1. Right, so it'd be a negative x and a -6. So when you simplify that, you get 2x minus 8. All right, if we divide each term here by 2, we get 34 is x minus 4. Add 4 to both sides, and we get 38. All right, in this lesson, we learned about the exterior case of the secant angle theorem. Thank you for watching this video.